This is another very important rearrangement of the organic nitrogen compounds. This rearrangement is known as Beckmann rearrangement. The question asked is, explain Beckmann rearrangement. We would like to discuss some details relating to Beckmann rearrangement. What is first of all Beckmann rearrangement? Beckmann rearrangement is the rearrangement of the oximes, particularly the unsymmetrical oximes. We will start with the ketone actually. We will start with the ketone, like this ketone is acetophenone. We have, this is phenyl methyl ketone or acetophenone. This acetophenone reacts with hydroxylamine to give rise to an oxime which is known as acetophenone oxime. Acetophenone oxime. This acetophenone oxime can exhibit geometrical isomerism, a type of geometrical isomerism where the OH group can be on the side where the CH3 group is located, or the product can also be C6H5 CCH3 double bond NOH, where the OH group is on the side where the C6H5 is located. So we have two geometrical isomers. One is known as, this OH is anti to C6H5, and whereas this OH is anti to the methyl. Therefore, we can have these two. Generally, normally in the case of cis trans isomerism or in the case of geometrical isomerism, we use the words cis and trans for those groups which are on the same side or on the opposite side. Here we use syn and anti, SYN and anti. What is more important is the group which is anti to OH, because there are only 3 substituents around the double bond. Therefore, we make use of the term syn and anti, and we don't make use of the term cis and trans for this type of the geometrical isomers. Therefore, we get 2 different types of oximes on the reaction of ketone, and this is the more important thing is, this is an unsymmetrical ketone. What is meant by an unsymmetrical ketone? The 2 groups attached to the carbonyl group are different. One is phenyl and the other is methyl. Supposing both are phenyl, as for example, this is a symmetrical ketone where we have the 2 groups that are attached to the carbonyl group are the same. Therefore, this is known as diphenyl ketone, or this is otherwise commonly this is known as benzophenone. But this is not generally important. Beckmann rearrangement is not generally important for symmetrical ketone. This is more important for unsymmetrical ketone. That is why we have taken this as a specific example. So this acetophenone forms 2 oximes. How to find out whether this oxime is formed? This oxime means what? One OH which is anti to C6H5, or this oxide is formed, which means whether the OH is anti to CH3. How will you find out? When this is subjected to Beckmann rearrangement, when these 2 oximes are subjected to Beckmann rearrangement, this will give rise to 2 different products of Beckmann rearrangement. So, Beckmann rearrangement is therefore, it doesn't start with the ketone, it starts only with the oximes. So, Beckmann rearrangement is a rearrangement of the oximes to give rise to some substituted amides under the treatment with PCl5 or acid. So, I will just write, we will first take up this oxime and then we will discuss about the Beckmann rearrangement of this. Supposing in this oxime, this is actually anti to C6H5. When this is oxime is treated with PCl, PCl5 is one of the reagents that is used for the Beckmann rearrangement. So what actually happens is, this PCl5 reacts with substitute. OH is generally a poor leaving group, and it is treated with PCl5. This will become C6H5 C N O PCl4, then CH3. After some time, this OPCl4 goes as a good leaving group. It is a very good leaving group. Therefore, this group leaving behind a nitrene. Just similar to the Beckmann rearrangement, this also gives rise to a nitrene. So, the group that is anti to the OH, which is actually this, migrates. So, this is the migration of the phenyl group. Then it is actually attached, previously it is attached to, or initially this is attached to carbon, now this is attached to nitrogen. So, what will be the product that you are going to get? You have the C6H5, then we have N double bond CCH3. When it is subjected to water, when it is treated with water, this will give rise to NHCO CH3. So this is the product that is obtained if this oxime is used. Therefore, the rearrangement of the oxime to give rise to a substituted amide. We can easily find out this is the acid part of the amide, this is the amine part of the amide. Amide is a mixture of, is something like a product that is formed between an acid and an amine. This is the amine part. Therefore, this can be called as N-phenyl acetamide. This is acetamide. Supposing it is NH2, this is acetamide. This is N-phenyl acetamide is a product that is obtained from this compound. So this is known as Beckmann rearrangement. Beckmann rearrangement is the rearrangement of an oxime to give rise to a specific product. This is very important in the case of unsymmetrical oximes because the two groups attached to the carbon are different. Now let us take the case of this compound. What will happen? The group that is, what will become, this will become OPCl4, this will be leaving away, and then this methyl group will be migrating to the nitrogen. So what will be the product that is going to be obtained? CH3, NH, CO, C6H5. So these are the two products that is formed. From this oxime, say 1 will be given this compound and 2 will be given this compound. Will undergo the rearrangement to give this compound. Therefore, we will find the name of the compound here is N-phenyl acetamide from this oxime and N-methyl benzamide from this particular compound. So we can find out, supposing the question is asked, acetophenone undergoes Beckmann rearrangement to give rise to an oxime, and acetophenone oxime undergoes the Beckmann rearrangement to give rise to a product which is this. Then immediately you can say the structure of the oxime formed is this. But acetophenone oxime undergoes Beckmann rearrangement to give rise to a product like this. Then you can immediately say that the oxime formed, the structure of the oxime formed is this. What does it actually mean? The OH is anti to C6H5 is anti to the OH. Supposing this compound is formed, CH3 is anti to OH. This is what is actually known as Beckmann rearrangement. This is one of the very important rearrangements of the oximes. The most important thing is a nitrene, an electron diffusion nitrene is obtained from which one of these two groups migrates. Which group actually migrates? One which is anti to the OH migrates.